My name is Wielgopolan. I work for the Institute of Geophysics, Polish Academy of Sciences. And today I'd like to share with you some basic information about geoengineering and also maybe learn your opinion or make you have some opinion whether it's damnation or salvation for Earth and for future generations. So, what is geoengineering? Well, it's quite a long word and a tricky word. It's actually an idea of applying planetary engineering to Earth. What does it mean? It means that we intend to fix the planet, fix the problems of the planet with engineering tools. And mostly it's not only limited to climate change, but mostly it's understood as counteracting current climate change. Actually, it's a totally new concept. It can be traced to the early years of the Cold War. And during that time, scientists, both in the United States and Soviet Union at that time, spent a lot of money and time trying to control the weather as part of their military strategy. Geoengineering is like literally Earth engineering. Nowadays it's a fashionable term and it describes large-scale interventions or abrupt interventions in how the planet works to slow down or reverse the effects, in this case, of climate change. So we're trying to rebalance what has changed and what we actually contributed a lot to changing. So it's a large-scale intervention, it's not local, and it's directed at reversing some processes that we are afraid might change Earth in a way that we do not like. So, like I said, it's not a totally new concept. Weather control has been a dream since ancient times. People were trying to ask gods to send rain or sun or sunny weather or anything. People were tempted to control every aspect of their surrounding with development of technology. So some people claimed to be able to bring rain because in times of drought, like during tribal dancing. They were showmen, rainmakers, who were traveling across West America, Wild West, and claimed to be able to control rain. And there were, but this was only fraud, or well, it did not involve any serious technology. In 1932, the Soviet Union established the Institute of Rainmaking in Leningrad, and it was the beginning of decades of experimentation with creating clouds, with so-called cloud seeding, and the goal was to alter the weather. And then in 1946, the United States created a similar institute where the researchers, for example, discovered that dry ice stimulates ice crystal formation. So both superpowers, Soviet Union and United States, carried out hundreds of experiments using solid carbon dioxide, silver iodide, and other particulate matter to trigger some changes in the weather, for example, to trigger precipitation. And they didn't have so much success, but it was still developing, and the first recorded and official use was a military use during the war in Vietnam, when this creating clouds was used to extend monsoon period in the area, so that the army, the Viet Cong, has less chance against American troops. So the scientists and the international community began to understand that this is a serious issue, and in 1976 there was an environmental modification convention ratified by United Nations, and it was like a treaty against hostile use of climate manipulation. And this is, well, more and more events like this, some local, some more global scale, took place. For example, in 2008, during Olympics in Beijing, the Chinese used weather control systems to delay a storm. So this is real, and there are also programs financed by, for example, US for technical evaluation, at least, of those tools. But what are the main tools used in geoengineering for now? First of all, there are three main types of approaches. But first, before we start this, let's look at the causes of climate change, of course. So, because the approaches are very much related to the causes. So, the problem is that too much heat is accumulated. Of course, it's again a simplification. Is accumulated near the Earth's surface, and the temperature is rising because carbon dioxide and other greenhouse gases do not allow the heat to go back to the space for many reasons. And as a result, we have this global warming in general, or climate change more accurately. To show you how the carbon dioxide content in the atmosphere changed, atmospheric CO2 in ppm, let's watch this little animation. What you see here, we'll start moving, is year by year content of CO2. 1984, 85. Here you can see it on the right. You can see a trend forming. On this map with those blinking dots, you can see locations from which the measurements are taken. And what you see here, this graph moving constantly up, is the average amount of CO2. Now we were in 2000, started from 3,350 ppm to 9, and it's constantly growing. 2011, and the trend is more than obvious. And yes, we exceeded this line, this boundary of 400 ppm, which hasn't been exceeded in millions of years. And the content of CO2 does not drop. So in the pre-industrial era, before we started, it was 278 ppm, and in the meantime, it grew. And in January 2017, we had 406 ppm, so the largest since. And in ice ages, of course, the content of CO2 was much lower. Okay, so the problem is that too much heat is it's near the Earth's surface, so not enough heat is sent back to the to space. Well, what can we do? We can have two, or there are two main approaches, and a third one accompanies as well. So we saw that carbon dioxide content is growing, so why don't we just remove the carbon dioxide? And the other approach is it's called solar radiation management. That means, in general, let's reflect the heat back to the space using lots of stuff, maybe mirrors, maybe something else. Let's increase albedo, so on and so on. And general idea is to reflect the heat back to the space. And the third one, less explored, is so-called Earth Radiation Management, ERM. So we have CDR and SRM and also ERM. So these are different kinds of technologies that are used to intervene in the land, in the oceans, in the atmosphere. And those techniques basically constitute what we call now geoengineering. So now, yeah, this is this is a graphic representation of general idea. So here's what we call cloud seeding. Cloud seeding means that we are creating clouds. We are expelling some nuclei, that is some particles, into the atmosphere, and the clouds are forming, and they are like a layer, a protective layer, or something that allows to reflect the heat back to the space. Some other ideas, I'll go to them into detail, but here we can see iron fertilization of the oceans, pumping CO2 into deep ocean, sending aerosols in stratosphere. This is cloud seeding, but also some of the craziest ideas were placing giant reflectors, giant mirrors in the orbit, and reflecting the sun radiation back. Or some said that maybe we should put a white blanket on Greenland, and the albedo will grow, so the temperature will drop, or at least will not rise so quickly. Is this totally science fiction? Is it just a theory? Well, no. It already exists. Actually, there are two plants, two factories like this. That are, one is in Germany, and the second one was built recently in Puglia in Italy. And this is how it looks like. I will show you a short video in a minute. So the general idea is capturing CO2 from the air. Now I'd like to show you some of the technologies. Some of them are already used, and some are only in test phases. None of them are widely used, actually, because this geoengineering is still, well, first of all, it's causing lots of controversies. And remember, these are all in those trends, two types of activities. One is capturing CO2, getting rid of CO2, and the other is reflecting or limiting the amount of solar radiation that reaches the Earth's surface. So let's start with an easy one, and quite common, CCS, and this is a shortage for carbon capture and storage. Actually, those people from Climeworks also mentioned that some of the CO2 that is captured from the atmosphere, from the air, can be stored like this. General idea is to filter out carbon, in this case from a factory, but maybe also generally directly from the air, and then store it somewhere. The problem is where it should be stored. Some talk about mines, old mines. Some talk about some rocks, but not all the rocks are suitable, because some are porous, and then gas, CO2 can get out. So, and is it 100% safe? So another idea is, or rather hypothetical example, involves feeding this captured CO2 to algae. And algae are supposed to produce biofuels, and this would be a better way of transforming CO2 into fuel. And another idea is to first capture, then store CO2, and then initiate reaction of CO2 with so-called calcifying minerals. Let's say, in general, calcium-like chemical substances to produce something. We can produce concrete for building purposes, for example. Well, it's not a large scale at all for now. Another one is actually from this second type, because this time, in the case of stratospheric aerosol injection, SAI, we do not absorb CO2 from the atmosphere. We actually we are attempting to get rid of too much radiation. So the idea is that we are supposed to use artillery guns, something like this, to reach the sky, and then we'll spray empty particles from back of the aircraft, for example. So in this case, mostly sulfides are the most studied option. So the idea is to spray sulfides or maybe other particles into the stratosphere in order to block the sun, because sun radiation, solar radiation will reflect from those particles, and as is seen on this image, is supposed to go back to the space. Actually, it sounds great. It's quite cheap. Those aerosol injection field experiments already have taken place in Russia, but there are many negative sides or maybe fears caused by this method. First of all, sulfides, spraying sulfides into the atmosphere is causing some concern, and also this technique would likely cause droughts in Africa, in Asia, and that would endanger the source of food and water for 2 billion people. So that's a high price to pay. So there is an unequal global impact of this method, and who is supposed to decide where to improve the climate or where to destroy it completely? So also, this technique could potentially be weaponized. Weaponized, that means it would be turned into a weapon. It could have military use. So who gets control? Who gets this weapon? And the other idea was to spray not the sulfides, but seawater into the atmosphere to create more white clouds. The other idea seems rather nice. The idea is to use high albedo crops. That means to plant plants that have naturally high albedo. That means their leaves reflect lots of solar radiation, or maybe more likely to use genetically modified crops for high albedo varieties of existing crops, so that they reflect, so those big surfaces covered with these crops would reflect more light. Farms and plantations, well, this seems to be not that bad idea. Maybe the fact that we would alter ecosystems in one way, and we would plant, for example, one type of plant on a large area, could be destroying ecosystems. It depends on where we could do it. It would definitely damage biodiversity. The other idea related to planting is a little bit different. And this was a type of reflecting sunlight, and the other one is the other type, sucking to this excessive CO2. So the idea is to plant lots of plants that are very CO2 hungry. That means they need a lot and absorb a lot of carbon dioxide for photosynthesis purposes. For example, azolla, that you can see here, a tiny but fast growing fern, and it eats a lot of CO2 from the atmosphere. The other one is very, very controversial, and as you can see, this is again type of solar radiation management. And the idea is, for me, it's actually quite stupid, but this is my opinion. So the idea is if the white surface, like snow-covered surface, reflects lots of light, reflects lots of solar radiation, that means maybe we should cut down the forest and to expose these white areas so that the light can be reflected. Well, this is controversial for many reasons. First of all, it would be reflected, but we would have no forests, boreal forests probably. So cutting down the trees is not the best idea, especially taking into consideration that trees are consuming lots of CO2. So this is one thing. And another thing is, I believe that the reason why the ice cover is so long-lasting in these areas, at least one of the reasons, is that the trees are there in the first place. The forest preserves snow. If you live in the area where there is snow, at least from time to time, you must see that in the forest, the snow is left for a longer time than, for example, on a street or on a meadow. So for me, this is not a good idea. It could destroy ecosystems, especially subarctic ecosystems, because this is where there are trees and snow cover. And productivity would be lower, animals would be affected, so not the best idea. Oh, this one is interesting actually, because again we're dealing with clouds, and this one is an example of Earth radiation management. That means this third type of approach in geoengineering. So it deals with cirrus clouds. And cirrus clouds are those clouds. I'm sure you recognize them. They're feather-like, very delicate, like lacy clouds. And the cirrus clouds do not reflect a lot of solar radiation back into space. But because they form very high, they form at high altitudes and in cold temperatures, they actually trap the radiation. And they have a climate impact similar to greenhouse gases, those cirrus clouds. So we don't want them. And the idea is to inject dust where cirrus clouds form, so that not they disappear, they become thinner and thinner. Using drones, for example. This is only an animation, it's not a real image, but the idea is to put dust there and make them thinner, and then they will be able to release the heat into space. Oh, the other idea is about carbon dioxide removal, mostly. For me, it's a little bit of combination. So the idea is to fertilize ocean. That means to dump nutrients, in this case to dump iron, into the ocean in the areas when the biological productivity is low. And when we put nutrients there, then phytoplankton is supposed to thrive, and lots of algae are supposed to appear. So the theory is that, for example, that there will be lots of phytoplankton. It will absorb atmospheric CO2, and then there will be too much phytoplankton, and it will die. And it is also a part of this process, because when it dies, it will fall to the ocean bed here, and be like sequestered, like in this technique when we're catching the CO2 and putting it in some hole, like in an old mine. In this case, it is supposed to be sequestered in the ocean bed. Will that happen? Well, we don't know for sure, because lots of things can go wrong in the process, actually. Also, causing those artificial plankton blooms can have very negative consequences for ecosystem, at least locally. Oh, this is an interesting one. Another example of technique involving carbon dioxide removal. It's called enhanced weathering. And those, you know what weathering is? It's not an obvious term for those who are not native English speakers. So, what is weathering? It's not true that it has nothing to do with weather, but in general, it's not about the weather. It's about something else, something more solid. Okay, you can see one participant who has no idea. Okay, maybe the description will help you. So the idea is to crush lots of minerals, silicate minerals, and spread them in oceans on land. So weathering is a natural phenomena dealing with rocks. So rocks are weathering because of weather, because of wind, because of sun, because of temperature, because of rain, and so on and so on. And this is what weathering is. So I'm sure you observe that the rocks are changing and landforms are forming because of weathering. So in this case, the idea would be to crush some minerals like rocks and spread them in oceans and on land. And why would that even help? Well, this technique is supposed to again initiate a reaction with atmospheric carbon dioxide. So again, it would attract atmospheric carbon dioxide, and it would form new rocks, and it would be trapped in oceans and soil. Actually, it's not that stupid idea, because it did happen in the past. During like millions of years ago, there was a lot of CO2 in the atmosphere, but it was always in balance with weathering of rocks. So this would actually happen. But doing it artificially might not work totally, but actually it's not, as you can imagine, it's not causing a lot of trouble. It can damage the landscape a little bit, but we're not using any chemicals, we're not spraying anything into the air, so we're just spreading rocks, and lots of rocks, lots of minerals, but it couldn't hurt the environment that much. And another one, oh, I like this one, it's called microbubbles. And again, microbubbles, you might think it's about capturing CO2, but actually it's about solar radiation management. So one question for you, the ocean, imagine the ocean, but the Arctic Ocean maybe. Is it dark? Is the surface of it dark or light? It's a tricky question, actually. And usually for the tricky questions, the right answer is that depends. Okay, are you imagining this right now? This ocean surface? Okay. So if we're in the Arctic, and let's say it's December, there's lots of sea ice. So sea ice is white generally. It looks white at least. So it reflects lots of solar radiation. It doesn't absorb it, so the radiation is going to the space. Well, unless Cirrus clouds stop it, but let's assume it goes back to space. But in the areas when there is no ice, where there's no ice, the surface of the ocean is probably almost black, like very, very dark. So the ocean absorbs energy. And if it absorbs, attracts energy, it means it contributes to global warming. So what to do? Well, we cannot put sea ice everywhere. That would be very bad and impossible for many reasons. So the scientists thought that why don't we create a foam? Like a foam. It's white, at least it's brighter than the surface of the ocean, and it would reflect more solar radiation. Sounds nice as long as the foam is created with oxygen. That means we are creating lots of waves, like in the water or behind your. If you ever went by boat or motorboat, especially, so behind your boat there is this white line, and it's just water with lots of oxygen that creates this kind of foam. But unfortunately, it wouldn't be possible to use a million motorboats, and unfortunately, we'd have to use chemicals again. So this is a very negative aspect of it. So the chemicals would allow this foam to be formed. And those millions of tiny air bubbles would reflect light of the ocean. At least this is the idea. Where do the scientists get the ideas from? Well, from various sources probably. Sometimes it feels like crazy science, but some of the genius ideas, most of the genius ideas, seemed crazy at the beginning. But actually, in some ways, we're trying to imitate nature. Like we're trying to imitate sea ice with microbubbles, and so on. Or we're trying to use what nature offers, like those plants that are very, very CO2 hungry. So we're trying to make large plantations of them and absorb as much CO2 as possible. And the other idea about putting or spraying dust into the atmosphere actually also comes from nature. I know you're too young to remember 1991. Unfortunately, I'm old enough to remember it quite well. So it was a giant eruption of Mount Pinatubo. It was a volcano, and during the volcano in Philippines, and there was a lot of lava and ashes, and it blasted out like 20 million tons of sulfur dioxide. Sulfur dioxide, so it sounds familiar in terms of geoengineering, and it left lots of tiny particles hovering in the sky. And all those particles, all those aerosols were dancing in the atmosphere, and they were reflecting more sunlight back into the space than usual. And it's not just a theory. After the eruption, the temperatures really, really dropped. And actually, I do remember that it was an extremely, extremely cold summer in 1992. Well, it was not a climate change because just an event and it wasn't a trend, but it was only impacting weather at that time. And this event was biggest of its kind in recent history, at least recent history. So scientists had a great opportunity to study it carefully. And actually, it was an inspiration for lots of solar geoengineering techniques. So now they're considering to spray it themselves. I was already trying to share some of the concerns related to geoengineering with you. Maybe you have some other ones. There are some societies, some communities that are really seriously monitoring development of geoengineering techniques because, well, first of all, we're not sure what the outcome would be, what the final outcome, taking into account all the parameters, would be. Actually, our lesson dedicated to chaos theory is a good example, because we literally do not know what the input is. We may measure everything, but nature is bigger than that, and we may not be aware of some aspect. And one tiny mistake, one tiny error can have major and catastrophic consequences. So if there are impacts, we don't know if we will be able to reverse them. Probably not. Who gets to decide how to act and where to act? It has global consequences. So which country, or maybe United Nations, or who should decide which technique to use? Of course, the techniques can also be used militarily, as usual, as a terrorism act. Weather might become a weapon in war. So these are all very serious concerns, but actually IPCC report, I think you know what IPCC is after our previous lessons. So IPCC reports actually gives geoengineering research tentative approval. And well, there is a dilemma whether to invest in geoengineering or not, because there are pros and there are cons. And probably we are not even aware of all the consequences. But these are only some of the examples. Of course, it would probably stop the symptoms of global warming. This is the primal goal. Some of the techniques are not so complicated and not so money-consuming. So they're affordable and they're feasible to do. Some of them. Some are really crazy, like putting a blanket on Greenland. And some have been proven to work. So it's something that works, that we can afford it, and it will, well, stop the climate change, which is a great challenge, a great issue nowadays. But there are also many, many downsides, very practical ones. For instance, it would probably reduce rainfall, and reduced rainfall means disrupted water cycle and droughts, especially in some regions. On regional level, on local level, climate would worsen. It would not get better. Also, it wouldn't solve every problem, and it would change the way, for example, sky looks like. So the sky would be white. The most geoengineering plans would create a whiter sky, like constant cloud cover to shield the sun. It may also destroy atmospheric ozone, and it means that without atmospheric ozone, we're coming back to ozone hole and dangerous UV light reaching the planet's surface. So we wouldn't avoid some negative consequences. And so this is why it is controversial. In many ways, it's unpredictable. It is still very expensive. Well, once I said it's affordable, it is affordable, but there is also a dilemma. Should we invest in a way to avoid emissions of CO2, or should we invest in geoengineering? So we continue using fossil fuels, but on the other hand, we are absorbing CO2 and everything is okay. So this is what the critics say, that it masks the real problem. So we want to continue our destruction and still be able to live on the Earth. But I think what my personal opinion is, of course, if I can share it with you, and I'll be happy to hear your opinions, is in this sentence: start thinking the unthinkable to avoid the unavoidable. My idea is that like 70% to 80% of all the effort, of all the money, of all the research should focus on replacing fossil fuels with renewable energy, with new resources, and so on and so on. So we should avoid emissions. But we're not sure what the future brings, and this 20% could be devoted to geoengineering, because it may bring solutions to the problems we don't know we have yet, more or less. So I wouldn't, if I was to decide, I wouldn't abandon this kind of research. I would treat them with, they wouldn't be my primary goal, especially because of the environmental consequences, and there are lots of them. Some say we would be adding chaos to complex and not fully understood systems. So this is a whole list of probable negative impacts on ecosystems. And the risks are, for example, and a very serious one, ozone layer decrease. I already mentioned we would probably have less ozone layer, and we would be endangered by UV radiation. It would probably lower biodiversity if we changed the crops. There is no switch off. If we spray something into the atmosphere, there is no way of reversing it, and we cannot control it fully. And there's also something called termination shock. Termination shock is something that happens when the technology is abruptly stopped. For example, there is a war or natural disaster or sabotage or terrorist attack, so we stop the technology that we're using, like we're no longer spraying dust into the atmosphere. So if this took place so abruptly, this would cause temperatures to rise very, very quickly, it would be very, very, very unpredictable. So we will be locked into technology, and this speedy rise of temperature could be truly catastrophic. And but the fact is, we are already engineering the Earth in many ways, like with drain rivers. We're painting Earth black, actually, with our infrastructure, with our habitats, with deforestation, with altering atmosphere, with pollution. So maybe we are geoengineering already, and what geoengineering means is to do it in a more conscious and responsible way. One thing to end with, in 2019, actually in early 2019, there will be a philanthropically funded project, stratospheric controlled perturbation experiment, SCOPEX in short. So Harvard scientists will attempt to replicate this cooling effect of volcanic eruption, like maybe not on the scale of Mount Pinatubo, but this will be a first solar geoengineering experiment, and it's set for early 2019. So they will inject calcium carbonate above the Earth, and they will hope that it will reflect some of the sun's rays back into the space. So it's worth to observe it. It will probably like this. So they're trying to recreate what Mount Pinatubo created, and this is what they hope to achieve, to reflect the sun back into the space, at least some of it. Okay, thank you very much.